Okay, so that was my solution to part I. Okay. Similarly, you can then substitute those 3 points into x plus 3y and determine which coordinate, which vertex will give you the maximum in that case. Okay, I'm not going to do that, but I would just like to show you where this is coming from. So the 3x plus y. Okay, so let's consider 3x plus y. Okay, and that is equal to some number. So let's say that's k. If we rearrange this, this is y is equal to k minus 3x. Okay, so that is a straight line. It has gradient of minus 3, so that's quite steep. Let's choose a value for k. Let's say it's, well, let's go for 40. That makes sense. Or let's go for 39, just to be different. Okay, so y is equal to 39. Take away 3 lots of x. Okay, here is the straight line. Let's make that a bit bigger actually. Let's change that from 39. Let's make that a bit bigger. Let's turn it into 50. Okay. So you can see if I keep increasing that letter k, the last point that it's actually going to hit that's in the feasible region, let's put 60, will be the point hit down here. Okay, this straight line can move across, and the first point it will hit will be this one, which is the maximum point that we found. Okay, 16.8. And that's kind of where our solution is coming from. If we have a look at the second equation, let's just change the colour. I'm a bit bored of that. Let's change it to a nice dark red. So x plus 3y, and let's say that that is equal to a number c, say. Well, if I rearrange this, I can write this as y, so I'll move x over to the other side and divide by 3, so I get c over 3 take away 1/3 x. So this line still has negative gradient, but the gradient is this time minus 1/3, which is a lot less steep. Okay, so let's put that in as, let's get rid of that line there, and let's change it to, let's say 30 take away 1/3 x. Okay, so now you can see it's not such a steep line, and when it's approaching the feasible region, we would probably expect that the first point it's going to hit is actually going to be this point here, so 426. Okay, so that will give you the maximized, the maximum coordinates in this case. It will give you the maximum value of f. So 426, 26, 52, 78 plus 4 is 82. Okay, so that you should be able to find that f is 82, and that'll be the maximum value in that case. Okay, so I know I haven't done this by hand, but I hope it's given you a good idea of how we're actually plotting the lines, looking for the feasible region, looking at the vertices and looking at each one individually and substituting in to, in this case, our f function, and how the steepness of that line changes which vertex is the best.